It's also my pleasure to chair this session of three keynotes from three excellent people. We're going to start with Professor Tim Sparks from the University of Coventry, also Coventry University. Coventry University. Tim is a professor in environmental change. Tim will be known to a lot of people as a leading light in the world of phenology, and we look very much forward to hearing from you. So I'll hand you over to Tim.
Thank you, Glenn. Well, I've got far too many slides, I know that, so I may skip through some of them as we progress through this talk. And I'll also upset a few nationalities like New Zealanders as we go along. So that's almost going to be inevitable, I'm afraid. This is, just out of interest, this is Robert Marsham's family home in Norwich, and I'll come back to Robert Marsham in a minute. But I'm going to try and cover quite a lot of material today, so I need to do that fairly quickly. I'm going to give a very, very brief bit of history about phenology, and then I'm going to move on to some of the varied examples that we get in phenology, and while I'm doing that, some of the challenges that are facing the phenology community as we go along. And I'm going to make apologies for any continents that I might miss out, and for any topics of phenology that I might miss out as I go along. Now, the oldest data that I'm aware of is from about 2,300 years ago, when the ancient Greeks were recording calendars of nature. So this is one of the students of Aristotle who recorded the events when migrant birds returned to Greece and flowering and so on. And we've also got some very, very good long-term records from Japan that go back to 700, from China that go back to the 1500s. But in the UK, most of our recording starts in the early 1700s. And this is Robert Marsham, the character whose house I showed at the very beginning. And he's the person that I like to think of as the father of British phenology. He started recording in 1736. And then whilst he died in 1789, his son continued recording, and then his grandson, and so on, right down until 1758. So there's a record of about 200 years of recording by a single family in a single location. And that provides us an excellent record of phenology. And as an example of that, these are his dates for, the family dates for Hawthorne. There's 176 years worth of data here from one location. And you can see the relationship here between temperature on the x-axis here and the day of the year up here. So as you all know, day 121 is May the 1st. You can just count from January the 1st onwards. And there's this very strong relationship with temperature. Now, we can argue about whether that's linear or not, and almost certainly it's not linear. But whether it's good enough to pretend that it's linear for most modelling purposes is another matter. So certainly in the cold years, it does look like there's almost no response to temperature in these very cold years, and that looks almost flat to me. And then above a certain point, there is a temperature response. So we may be dealing with a broken stick type model, where the response to temperature increases only at higher temperatures. There's a very, very wide range of phenology topics, and I will have left some out here. And at the top of that, I've included ice. Now that's going to offend some people in this audience, because they think phenology can only deal with biological events. And I think phenology deals with naturally recurring events, which would include ice phenology, for example, and would include other aspects which I'll talk to, other human activities which I'll talk to. There's a whole raft of activity in the marine area, which we rarely see. It's the marine people tend to stick to themselves, and there's masses of data about marine phenology, which tends to get into specialist literature and occasionally into the more broad stream literature. So there's a very wide range there. I'm not going to mention marine today, I'm not going to mention birds today, and a whole load of other things. Now there is a very wide range also of methods of recording, and I'm going to show some of those examples as we go along. They range from the very rigid, very constant effort schemes to record. They're the byproduct of monitoring programs, and there's also the very much looser citizen science type schemes where people are just recording what they want when they want. And it's that sort of scheme that's now used in, for example, in the Netherlands, in the UK and the USA, and in other countries. It's a much more rigid station-based system for recording phonology. And it takes many forms. So this is a diary record, typical diary record of a story. And people who record phonology are OCD. Let's not argue about it. People who record the same thing year after year after year are obsessive compulsives. So this guy was recording the birds he saw every day for 58 years. And this is his record from the 3rd of September 1939, which is quite an important day. And he records a list of birds and then casually mentions that Britain and Germany have gone to war. So this is an indication of the type of person that will be recording, well, perhaps the type of British person that's recording phonology. Diary entries. This is card index system. This lady who lived just not far north from where we are now recorded for 50 years every plant species that she could identify, which is about 200 plant species, and she kept it in a card index system. Some people don't record on paper. This guy paints every year the date of daffodil flowering on his shed door. So we've got paper records, we've got diary records, we've got card index systems, we've got buildings. And if you think this is just one odd person, I can find you at least another dozen people who've been recording on buildings. You know, they've got a lunch hut and they record the dates on the windowsill or something of the lunch hut. And we've also we're now exploiting records from herbariums and records from museum specimens where these specimens, whether they're plant or animal, will often contain a label that says where and when they were recorded. And these things are gradually being digitised and gradually becoming more and more useful. And I'm going to upset some people by talking about some ice phenology. And this is, and I want someone to tell me how to pronounce this, Nenana in Alaska. Now, since 1917, they've had a sweepstake on when this wooden tripod is going to fall through the ice, and you can pay, I can't remember what it is now, it used to be $1, I think it's gone up now. This year, the ice melted exactly at midday. I bet that fooled people, it was exactly on the hour, on the 1st of May. The important thing is we've now got 101 years of this record. Oh, and the sweepstake prize was about $250,000. And it's got much more sophisticated now, so the wooden tripod is connected to a clock by a wire, and when the tripod falls through the ice, the pin comes out the clock stops, and you share the prize. They have to put guards around the clock tower near melt dates to stop people going and pulling the wire out of the clock. But we have this rather extraordinary length of record now. We've got 101 years of data on melting in Alaska, and it shows some features which are typical of phenology. When we talk about phenology as changing, I think the great British public think that we've had this nice, smooth transition from, things that happen late in the year to things which happen early. It isn't like that. It's very jagged. There's lots of variability in there. So there's more than a month variability in ice melt dates here, and I will just point out that's 2013. I'm going to come back to 2013 in a minute. So there is a huge amount of variation there, and this raises the whole issue, and I think someone mentioned this, Shell I think mentioned this yesterday, about baselines. Where do we measure change from? Why do we measure change here from 1917? And we measure change from 1917 because that's when they were building the railroad here, and that's when they started this competition. There's no other reason. Why shouldn't it have been 1929? If you were a president of the United States that dyed your hair, you might want to start in 1940 and end in 2013 because it would show that nothing is happening. The red line here is the underlying trend, by the way. And it is difficult. Where is the baseline? Where do you measure change from? Because I'm now getting old, but not as old as Glenn, my baseline would be somewhere here in the 1960s and 70s. Who laughed there?
Yeah, exactly.
Out. My baseline is somewhere here. But it's very, very sobering when I think that in a few weeks' time, the students that are starting at my university are going to be born in 1999. They're going to be up here. They're not going to remember the first few years. They will have experienced this tiny little fraction of this thing. And when you say that it's changed by this amount, they won't believe you because it's not in their memory. It's not part of their existence. For me, anything before about here is history. For them, anything before 1999 is history. And that's quite sobering. Where do we measure these things from? Why do we choose a particular date? And it's often because that's the date on which recording began. Let's just pretend for a minute we've only got 10 years of data. So if we had 1917 to 1926, we will just have these 10 years of data. You can see I'm very high tech. I've put a big white box over the rest of it. If we looked at just these 10 years, we would have a very slight negative trend. And I've seen papers, I get papers where someone's done what they call a long-term analysis of 8 years of data. And you can't do that with phenology. I mean, you can maybe get a preliminary look because it's a very unusual data set, but 8 years of data for mainstream events, no. So we have a very slight negative trend here. And if we took every 10-year period, that's that first 10-year period there. If we took every 10-year period in a moving window, sometimes we get negative trends, sometimes we get positive trends. Generally, the trends are below the horizontal, so that it's getting earlier. Occasionally, we'll get periods when there's a great deal of positive trend, and we'll come to the conclusion that ice is freezing later and the planet's getting colder. If we change that to a 20-year system in red here, you can see it damps down a lot, which is why we've suggested in the past that 20 years should be the minimum for this type of data. And if you take it to 40 years, which is the black line here, it damps down even further. So that the more years of data you can get, the more reliable will be your estimates. But the start date and the end date is still going to be very, very critical. Still in an icy location, there are not many phenological records on bears. So this is in the Russian Arctic Circle. This is the first brown bear of spring, or rather when they saw the first tracks of the first brown bear of spring. And there are problems with the data, like all these long-term series. The Second World War got in the way of data recording. You know, there's lots of gaps in the European record in the Second World War. Stalin got in the way of data recording in the 1950s, and when he did a purge on the scientists. But generally, since 1931, there's been this constant record of recording bears. Now, I guess that recording bears in the Arctic Circle is quite a difficult thing to do, because you have to go out, and it's quite chilly, and you have to look for bear tracks. And I guess if it's been snowing, they're not visible. And I imagine there's all sorts of problems associated with recording bear phenology. But you can see there's a very wide range of dates here again. Germany is probably the example of country when it comes to recording schemes. So they have had a scheme since the Second World War, fixed locations run by their National Weather Service, the Deutsche Wetterdienst. And for example, for this species, coltsfoot, there are 363 separate locations that have at least 50 years of data. You know, I wish we'd had that in the UK. We don't have that in the UK. I'm quite jealous. I'm very jealous of the German system. And you can get extreme changes amongst those 363 locations. So we have one site in Baden-Württemberg where it looks like the plant has got very much earlier, and the contrasting extreme site in Bavaria is where it's getting later. And you look at this graph and you think, they're all regressing to a mean. You know, everything's going back to a mean date, and everything's going to flower in Germany at the same time in the future. Well, sorry, it doesn't happen like that. It's a nice idea, but it doesn't work. We can look at all the trends from those 363 stations, and 3/4 of them are getting earlier over the period that we're interested in. So here we have the trends of those 363 stations. Everything in red has been getting earlier. So the bulk of the evidence is that these events are getting earlier, but there are examples where it's getting later as well. When we have long-term networks like this, it's very much more powerful than looking at individual stations. This is Jean Coons. This year we went down, we had a bit of a party because it's her 90th birthday. She's been recording now for 71 years. Now, Shell did a paper on a guy that recorded 73 years. Now, I'm hoping that he stopped.
He's dead.
He's dead. Has he stopped?
He's not dead, he's just resting.
Okay. I'm going to get her to beat your man. Jean Coombs is going to beat this. I mean, we may not be able to beat you at football, but she is going to beat you in terms of recording phenology. And this is one of her records. This is this is a single oak tree. She's followed the same oak tree since 1950. The red line is the underlying trend. You can see the huge variation you can get over the years, but you can also see that there's been a big change in recent time. We've had these very early springs with very early leafing. That's 2013, just to put it into context. Remember the cold year in Alaska? Also happened to be quite cold in Surrey, just south of London. We know that it's much easier to record plants than anything else because plants stay put. Jean Coombs was recording that one tree. She knows where that tree is. She walks past it every day. She can go there and record it. Animals are much more difficult than that. But despite that, you can get some remarkable synchrony, remarkable agreement between different people. Now there are 4 different people here recording this butterfly, the orange-tipped butterfly. This is the male because, like most species, the male is much more beautiful than the female. And you can see here that there is remarkable agreement here. These 4 people, one is a scientist, an agricultural scientist. One was a lady who recorded in a back garden, one was a farmer, and one was a school teacher. They don't know one another, they don't record in the same way, necessarily the same thing, but these records are remarkably consistent between them. And that gives us a lot of faith about what's happening. Citizen science schemes give us lots of data. In the UK, we can see the urban heat island effect of London, so that in this case, the flowering of horse chestnut is very much earlier, close to London, and then it gets later as you move out. Even when you move south of London, it's later, because there's a heat island effect of London, which has an effect there. Now, my own contribution to recording phenology is quite limited. And my colleague Annette Menzel in Munich really rolls her eyes whenever I bring out things like grass cutting. If I mention rhubarb crumble, she'd get really upset. So, it's a family tradition to have rhubarb crumble early in the spring. You can imagine that all the apples are gone, all the fruit's gone, you've gone through this miserable winter, you're desperate for the first crumble of spring, you're inherently tight, so you're not going to buy any fruit to go in a crumble. Crumbles have to be free things, they're free apples, or they're free blackberries, or they're free rhubarb. You don't buy fruit. So this is mine, and what's remarkable about it is I've missed a year. I don't know what happened to 2007. But they're all Sundays. So I only measure accurate to a Sunday. Because Sunday is when you have a roast dinner and a crumble. So there's rather limited, but when you plot those dates against temperature, you can still pick up a temperature effect. So let me just go back to that. When I come to the crumble, I don't put on a white coat, I don't go out and measure, I don't go and see how thick the petioles are or how long the petioles are. I just look and I say, is there enough rhubarb to go into my mum's crumble dish that I inherited when she died? Or not? Is there enough or not? And that's it. It's not scientific, but even with that I can pick up this temperature relationship. And I'll just point out again, 2013. Not only did it make the river in Alaska melt late, but it meant that my rhubarb crumble was late. So across the world, 2013 seems to have been a cold spring. I personally think that pictures portray a much stronger picture to the public than any other form of conveying information. Numbers people don't like. I work with students and numbers all the time, and students hate numbers. They can't cope with numbers. Graphs are just about acceptable. Photographs are much more important. Here again, 2013 in the bottom right-hand corner. All of these photographs are on April the 7th. Now, recording photographs over and over and over again, some people do it. There is a series from 19 15 to 1945, recorded by one man in Norwich, which is published in a book which you can get. But when you start recording these long-term pictures, you need to be aware that you can't always predict what's going to happen to some of the subjects that you're recording, and some of them do disappear in the course of time. This is a picture from, I think, one of Abe Miller Rushing's papers, which showed an American Civil War tomb in 1868, and on the same day, 137 years later, something like that. And you can just look at the trees in the background. There's a huge difference there. But I could have chosen 1 year to demonstrate late and 1 year to demonstrate early. So what we need is a series of photographs. We need to think about where we can get a series of photographs. In the Netherlands, there's the Queen's Day, 30th of May, 30th of April. It doesn't matter when the Queen was born. Well, there isn't a Queen any longer. What is it? What's the Queen's Day now?
I think it's common stuff.
Okay. I presume that's the King's Day.
No, I'm not.
Every year on the 30th of April, the Dutch go mad. They go orange. They celebrate as only the Dutch can celebrate. And you can see these are all on the same day of the year. This one, the Queen is wrapped up in a nice fur coat. 2 years later, she's there with her family. Look at the trees in the background. And this one is 1999. And there are huge differences from year to year. And you can get series of data that show these things. You can almost get complete series. This is the cenotaph in Whitehall in London, which commemorates the end of the First World War. The picture on the left is from the early 1920s. The trees in the background are London plains. This is 2004. The trees in the background are London plains. They're the same trees. It's the same day of the year. And last year it looked like that. You can see the trees in the background. Now, I was in Auckland in April, and this was there as well. This same memorial was there in Auckland, and I thought, because that would be their spring rather than our autumn, and I was wondering, are there a series of photographs of commemoration on November the 11th in Auckland as well? And then in South Africa, and then in Canada. And there will be a series of these photographs. If we just simply score these photographs from when they're leafless up to very leafed, in these early years, I've got data from Paris as well, because Paris tend to grow in France, on the Champs-Élysées, they grow London plains as well, but obviously they don't call them London plains, they call them something else. Lots of years at the beginning which are completely leafless, and then in more recent time we've had no years which are leafless, and there are some years which are still incredibly green on November the 11th. So photographs can provide us a great deal of evidence. We're now switching much more into things like webcams and remote sensing. So this is Harvard Forest, and the date here is April the 7th, the date here is May the 11th. We can capture these, we can convert them into red, green, blue frequencies, and we can look at changes, and we can get massive amounts of data from satellite. One of the big problems that phenologists get is that you can demonstrate change, and you can show that birds are migrating earlier and that leaves are coming out earlier, and everyone says, so what? What's the problem with that? Well, one of the problems with it, there is an economic cost with that. This is the peach potato aphid recorded at Rothamsted, which is just north of London. They have a 12.2 metre suction trap, which is essentially a vacuum cleaner. It sucks aphids out of the sky. It's completely automatic, and the date of the first peach potato aphid varies by about 17 days per 1 degree Celsius. I thought Glenn was going to tell me I've got a minute left then. So there's a big agricultural cost to phenology. This is a flower festival, a small flower festival near Cambridge. It attracts about 10,000 people every year. The title says 2018, and that is correct. We know the date for next year's flower festival because they have to book it to get the coach traffic in. So that's what will happen next year. Now, they had a big problem in this year. There was a knee-jerk reaction here because there were no daffodils in flower, and they moved the next year's festival back by about 3 weeks. And the problem was they then missed everything. So we had this problem where the Telegraph, one of the national newspapers here, said There's a blooming nightmare, which is a play on the language, of course. So it is a nightmare for the organisers to try and match the dates up to the flowering of the events. Some of the events, so this is Beijing, Cherry Festival, hugely economically important. You go to Japan, they're big. If you go to the Washington DC, if you go to Autumn Colours in New England, these are huge commercial, economic things. This only lasts at its peak for about 1 week. That's what's been happening to the festival dates from 1989. I did try and get them for 2017, but my Chinese failed me. I was only trying to do it at the weekend, but there's been an advance there as well. Fly fishing, hugely important. This is a record from about 1830 to about 1930. Again, you can see the huge variation in when this aquatic fly comes up. Now, this is when the rivers are going to be best for fishing in. And there was a huge problem at the time that it took 2 days for these people to get from London to these rivers. And they needed to try and leave London to get to the destination at the right time for catching fish. So they had all sorts of early models to try and work out that if the tulips were out in London, would the fish be jumping in Dorset? And all sorts of complicated models, but there's a huge variation of at least a month in there. Human health, these are the first flowering dates for major grass pollen and a major tree pollen, allergic pollen, and you can see that there's a great deal of agreement between these, but a great deal of variability. It moves by at least a month. What happens when seasons change? Does it mean an extended pollen season? There's lots of other people doing much better work on this. There's also criticism of these things when we're looking at first dates. You know, we have first dates. Oh, what are we actually recording? Is it the first of something, or is it something slightly different? And we can, for some series, we can get around that problem. There are some species that are directly reliant on one another. So for these two fungi, one is a parasite of the other, and it only parasitizes the other. What seems to have been happening is the host is changing its phenology and the parasite isn't. So ultimately, the parasite is going to be at risk because it's fruiting too late in the year. This is a well-known British flower, in blue here, the bluebell, and above it, an oak species, which would be its canopy. Now they need to remain synchronized because the plant needs to come out in flower, it needs to finish flowering, and then the trees can leaf over above it. And if they go out of synchrony, there's a problem. But in this particular case, bluebell could flower under ash, for example, rather than under oak. Here is the orange tip again. Remember the beautiful male butterfly? That's in blue here. It must lay eggs, the male mustn't lay eggs, the female must lay eggs into either of these two food plants. They're the only two that it will lay eggs into. So it needs to remain synchronized with that. And if the synchrony changes, yes, it could swap between either of the two food plants, and it does, but it must remain in synchrony with one or the other. And we know that there are big differences in the provenance of different tree species, for example, and we could probably accommodate some climate change by changing provenance of tree species. So here we have 5 different provenances of a Rowan tree, and the 6th one you can see almost is not doing anything. And if Alison had been here still, I would have said, this is the Irish one, and it is the Irish one. It's a very late, very slow provenance of Rowan, which we can accommodate some changes in climate by changing our provenances around. And in commercial horticulture, agriculture, we call those things varieties. And here we have just 2 daffodil cultivars, one which shows almost no change in its phenology, and another one which has advanced quite a lot. So we may be able to do some of these things. We are also still having problems. This is my particular problem. I showed you Coltsfoot earlier from Germany. In the UK, it seems to be getting later. And I can't explain this. So these are 2 records from 2 well-known recorders. They both show phenology of Coltsfoot's getting later when it should be getting earlier. That's my problem, not yours. And I'm nearly finished, and Glenn will be very happy with that. But just a word of warning that we talk about all of these things and we like to attribute them all to a changing climate. That's exactly what this was being done here with my local newspaper. But the trouble was that was 1933. So when we're talking about climate change, let's be very certain that climate is the driver of the thing that we're looking at and not something else. So this is my final slide, and I hope I'm reasonably to time. Phenology is a very varied area of science. The topics we look at are very, very varied, from things like pollen to things like marine plankton and everything in between. I think it's a very robust type of study. I like to liken it to a Land Rover. You know, you can drive it through mud, you can drive it through water, and you can still get time series which show responses to temperature. And I'm thinking about my rhubarb crumble probably more than anything else. We can show change, and we can show change in a huge range of things, but there are examples of data where either the reverse is true or we don't detect change. And we need to acknowledge those things, that not everything is changing. Some things are changing at different rates, and there are areas of the world where change is not being detected. I think phenology has the potential for demonstrating climate change impacts more than almost anything, because the public understand it. So if you talk about the climate has warmed by 0.74 degrees, no one can grasp what 0.74 degrees is. But if you say oak trees in Surrey are leafing 3 weeks earlier, they can visualise that and they can accept that. And particularly if they're older than my students will be in 3 weeks' time, and when they've experienced a much wider range of environments. Glenn, for example, who's experienced at least 2 centuries of the environment, will recognise that change has been going on from when he was... Were you young? Once.
Never young.
And there are consequences. So the so what question that we get, we do have answers to that. So there are consequences for horticulture, for agriculture, for human health, for tourism, and don't underestimate tourism, flower tourism and plant tourism. It is huge, and we tend to overlook these things. So I'll finish there, and I thank you very much.